Hello, grade sixes. Just going to go over your homework. This is page 283, Math Makes Sense 6. We did number 1 together, so we had number 2 to 7 due today. So number 2, draw a picture to represent each number. So A, it was 1 and 5/8. You could have also done this so this was just a whole without the pieces, one whole and then the 5/8, but you see this is like a pie or a pizza that's been cut into 8 even slices. So we ate 8 slices or one whole pizza, and then we ate 1, 2, 3, 4, 5 of the 8 potential pieces for here. For B, we've got 1 and 2/3. So we've got kind of a box cut into thirds. So we've got this whole box, so there's the 1. Okay, I've drawn the lines for the third, but you didn't need to for this one if you didn't. This one you divided the box into thirds, but only 2 of them are colored in because of just 2/3 of it. Okay, so that's 1 and 2/3. So I'll write that up there. That's 1 and 2/3. Okay, C, I'm going to just write below. Okay, that is 7/4. Okay, or 7/4. So we've got 7/4. So here we got, again, I'm going to say pizzas, but instead of cutting them in 8 pieces like number 1, I just cut them in 4 pieces. And then so there's 2 pizzas left. Okay, we ate 1 whole pizza and 3 pieces of the 4 in the other pizza for a total of 1, 2, 3, 4, 5, 6, 7 pieces. So 7/4. Okay, and then finally D. It is 9/2, and I have 5 blocks that are divided kind of into 2 pieces, and so we have 1, 2, 3, 4, 5, 6, 7, 8, 9 halves. Okay, so that might be like say a sandwich that you're going to cut into halves. So right here we got 1 sandwich. 2 pieces, or 2 halves, another 2 halves, another 2 halves of a sandwich, another 2 halves, but then only 1 half. Okay, so we got 2 halves, 2 halves, 2 halves, and only 1 for a total of 9 halves. Okay, so that is question number 2. So for number 3, 3 says write each mixed number as an improper fraction. Okay, so this is 1 and 1/6. So different ways you could do this. So 1, we could say it's 1 plus 1/6. I think that makes sense. That should make sense, right? It's 1 whole and 1/6. And then if we want to take that 1 further, how can we write 1 as a fraction with 6 as the denominator? That could be 6/6 plus 1/6 equals 7/6. So now we've taken this mixed number and we've made it into an improper fraction. Now the other way to do it would simply to be take right here, we got 6, go 1 times 6, and then add the 1 up here, plus 1 equals 7, and that would tell us how many 6. 7, 6. Okay, that's A, whichever your preference is. For B, 4 and 3/8. So we know it's going to be 8s, so it's going to, as an improper fraction, we know it's going to be 8s. 4 times 8 is 32, plus 3 is 35. Okay, 35/8. So we got 4 times 8, okay, is 32 plus 3 is 35/8. Now, if you wanted to do that the other way, we could say 4 plus 3/8, and then I'm just going to erase some of this here. Let's erase this. So say we got 4 plus 3/8. Well, it could be like 1 plus 1 plus 1 plus 1 to represent the 4 plus 3/8. And then another way to write the 1 on all these is 8 over 8 plus 8 over 8 plus 8 over 8 plus 8 over 8 plus 3 over 8 equals 35 over 8. So that's kind of more of a way to see that it makes sense to you. Okay, the way where you take it here and go 4 times 8 plus 3 is 35 over 8 is probably going to be the one that will be most helpful to you. I'm just going to erase this whole page and go on to C. So C is 1 3/4. Okay, so we know it's going to be in a quarters, and then we got 1 times 4 is 4 plus 3 is 7, or 7/4. For D, 3 3/5. Okay, we know it's going to be fifths. Just have to determine the denominator is going to be fifths. What will the top be? 3 times 5 is 15 plus 3 is 18. 18/5. Okay? And again, how we get that is because these is 3 whole numbers. Okay, so this is really like 15/5 is this represent plus 3/5. Okay? E, 8 1/2 equals 8 times 2 is 16 plus 1 is 17, and we're going to keep the same denominator. Okay. F, 7 1/4. Okay, 7 times 4 is 28, plus the 1 here equals 29 over 4. Okay, that is question number 3. I'm going to move on to question number 4 here. It says write each proper fraction as a mixed number. Okay, so this is just a little bit different. Okay, we've got A, 17 over 5. So 17/5 as a mixed number. How are we going to write this as a improper fractions, or how are we going to write it as a mixed number? So we got 17/5. So we could think, well, how many whole numbers can we get out of this? So we go, we've got, best way to do it is probably divide. So we're going to divide 5 into 17. Doesn't go into 1, so it goes in there 3 times. 3 times 5 is 15. And we have 2. Now 5 can't go in there anymore. There's nothing else to bring down. So this is a remainder. But what that remainder really always means is it's 2 over 5. Okay, so let's move this on. So this equals 3 2/5. Okay, all the times when there was a remainder, it really meant the remainder over the divisor was the answer. Okay, so that's 4A. So 4B, 9 over 4. Okay, so we've got 4 goes into 9. Okay, it goes in there 2 times. Okay, 2 times 4 is 8. And there's a remainder of 1. So the answer is 2 1/4. The denominator is always going to be these numbers that you're divisors that you're dividing in. So that's for B, 2 1/4. C, 18 over 4. 18/4. Okay, so we go 4 into 18 goes 4 times, 16, 2 left over equals 4 and 2/4, or simplify to 4 and 1/2. D, 14/3. Okay, well, 3 goes into 14 4 times to give us 12. So the answer is 4 and 2/3. Okay. I'm going to clear this page and just to finish the next ones. Open. So E, we've got 20/3. Okay, so 3 goes into 20. 6 times is 18. So we have 6 and 2/3 is our answer for E. And for F, 26. Okay, 6 divided into 20 goes 3 times. 18. 18 and 2 remainder, so equals 3 and 2/6, and that can be simplified to 3 and 1/3. Okay, so that is question 4. Question 5. Which of these improper fractions are between 4 and 5? How do you know? Well, 13/3. Is that between 4 and 5? So between, it's right up here. Well, let's just do what we did in the last one. 3 goes into 13. Okay. 4, because 4 times 3 is 12. So it's 4 and 1/3. So I'll say that is, check, that one does. So now we go for B, 13/4. Okay, let's say 4 into 13. Well, it's kind of the, last time it was 3 into, now it's 4, so it's a little different. So we got 4 times 3 is 12. 1. So the answer is 3 and 1/3. So this one, B, gets it doesn't work. C, 13/5. I can already tell by looking at this. I know that 3 times 5 is 13. It's not going to be between 3 and 5, but let's go through it anyway. 5 goes into 13. Okay, it doesn't even go 3 times. So 2 is 10 with a 3. So it equals 2 and 3/5. And lastly, D, 13/6. Okay, 6 goes into 13 2 times, so we get 2 and 1/6. So that one doesn't, that one doesn't. Okay, looks like only A is between 4 and 5. So question number 6 is Max baked 5 pies for the bake sale. He cut each pie into 8 equal slices. In the first 30 minutes of the bake sale, Max sold 19 pieces of pie. How many pies did Max sell in that time? Give your answer 2 ways. Well, I always like, for me, drawing a picture always helps me. So I decided to draw a picture. So I drew 5 pies and I cut them into 8 pieces. So, and I'm just, so it says here he sold 19 pieces. In the first 30 minutes. Okay, so they want to get two ways. So it says, well, we sliced it 8 pies. So how many pies did he sell? Well, if he sold 19 pieces, okay, I'm going to say that if I go, because we cut them into 8s, if I go 8 into 19, it's going to 8 goes twice, gives me 16, gives me 3 remainders. I'm going to say that he sold 2 3/8 pies in that time. Now, how do I know how many slices that is, though? Because that doesn't tell me. Okay, well, oh, that's, no, never mind. That's right. Sorry, 2 3/8 pies. So now, how else can we figure this out? Well, I'm gonna go to the pie here, and we'll just count the pieces, and it'll tell us how many pies. Okay, so we had 1 piece, 2 pieces, 3, 4, 5, 6, 7, 8. We're at 8 pieces. 9, 10, 11, 12, 13, 14, 15, 16. Okay, 17, 18, 19. Okay, so 19 pieces. We can see that as 1 whole pie, another whole pie, and 3/8 of another pie. Okay, so, oops. Sorry. So again, so we can see we have 2 whole pies and 3 out of 8 pies. Okay, so I'm just going to clear this, erase a little bit of this to do the next one, so I don't have to get rid of my pies. I'm going to pause the screen while I do that so you don't have to listen to me, so hold on. So B says, how many pies are left? Give your answer in 2 ways. Well, I'm going to say one way is, well, there's 5 pies. 5 pies, 8 pieces in each pie. So 5 times 8 equals 40. Okay, so I know to begin with, there was 40 pieces. But we know 19 are gone, so 40 minus 19 equals 21. So I know now there are 21 pieces left. Now the other way is, just to go back to my drawing, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. You can count the extra pieces. All the white ones are left. Okay, and if you want, so it's so pieces left. Okay, we've got, it's either 21 pieces, or if you want to do it in pies, there's 2 whole pies and 1, 2, 3, 4, 5/8 of a pie left. So 21 pieces left, or 2 5/8 pies. Question 7 says, suppose you get 0 as the remainder when you divide the numerator of an improper fraction by the denominator. What does that tell you? Use drawings and words to explain. Okay, so here I've drawn a fraction. So I've got, it's in the denominator, see they've been into halves. So the denominator is halves because each of my wholes has been divided into halves. And I've got 1, 2, 3, 4. 4 of them. Okay. So then if I can simplify that, okay, that actually becomes, I've got 2. And you can see by the picture I've got 2 whole and none left over. And you can see here I've got 2 whole. So what it means when you have a zero remainder, when you divide the numerator of an improper fraction by the denominator and you have no left over, means that the answer is a whole number. So like here it is the number 2. Okay, so in other examples would be if it was in thirds and it was 6/3 or 9/3. Okay, they would break down, they would reduce themselves to whole numbers, which, so this one would be 2, this one would be 3. That's all there is to that. Okay, thank you.